Welcome back to Beyond the Comfort Zone, the place where we take the dense, the complex, and the high-stakes world of professional architecture and really try to turn it into knowledge that is immediately actionable.
Today, we are absolutely wading into the deep end of project management. This is the area that, frankly, separates financial success from just, catastrophic fee burn.
It really is.
We're talking about how architects, acting as the prime consultants, manage the complex, often conflicting deliverables that come from their engineering partners. I mean, this is the difference between a project that sails through permitting.
And one that just sinks under the weight of its own uncoordinated documents.
Exactly.
That's right. And our mission today is laser focused on professional practice. We are doing a deep dive into the official source material titled Architectural Records and Professional Practices of the Services of KING-KAMBUF's Architecture Design Studios issue. Project Management, PjM, Coordinating with Consultants.
A mouthful, but important.
It is. Specifically, we're addressing the roles, responsibilities, and really the heavy lifting required for managing civil, structural, and MEP deliverables.
And we are essentially providing you with a shortcut here, a shortcut to mastering what we call the prime consultant mindset. Our goal is to equip you with the processes, how to plan the work, how to sequence deliverables.
How to review and integrate all that work from your consultants.
Right, all so that the total package of construction documents is perfectly coordinated, absolutely code compliant, and, most importantly, shovel ready and permit ready.
And here's the real high wire act, isn't it? We have to do all of this, achieve this seamless integration without crossing that critical legal boundary.
And accidentally assuming the engineer's professional liability.
Exactly. So we're going to be touching on pretty much every aspect of the project lifecycle here: project work planning, project execution, quality control, contracts, submittal workflows, and just the essential risk management habits that, well, keep your firm solvent.
Let's get into it.
Okay, let's unpack this core issue first. Why does the architect, who typically isn't designing the foundation or the ductwork, still carry the primary coordination responsibility? I mean, what is the contractual nexus that forces this on us?
Well, it's a simple chain of command, really.
Yeah.
It's established in the standard contractual model. The owner hires the architect, generally, as the single entity responsible for delivering the completed design service for the whole building. You are the nexus.
So it all flows through us.
It all flows through you. You sign the agreement that essentially says, I, the architect, will ensure that all these moving parts, the civil site work, the structural skeleton, the mechanical guts, all fit together into one coherent, code-compliant building.
So therefore, the legal responsibility for coordinating those parts just falls to you, the prime signatory.
That's it.
The sources outline two primary ways to do this, two contractual models for engaging engineers, and understanding which one you're in really dictates your authority, doesn't it?
It dictates your leverage, absolutely.
Let's start with the one that gives the architect the most leverage, the architect's subconsultants model.
This is by far the cleanest arrangement, especially for high-complexity projects. In this case, your architectural firm holds the direct contract with the structural, MEP, and civil engineers.
And that gives you direct contractual leverage.
Significant leverage. You have the ability to enforce schedules, to demand specific deliverable formats, to mandate coordination workflows. Why? Because they are directly accountable to your firm if they fail to deliver.
You have recourse.
You have the contractual right to withhold payment or, in really extreme cases, terminate their engagement. Subject to the contract terms, of course.
But then there's the second model, the owner's consultants model, and this is where we run into that classic coordination challenge.
Oh, yes. This is where the owner holds separate direct agreements with the engineers. Now, you, the architect, are still legally required to coordinate the total design.
But your direct enforcement mechanism is just gone.
It's greatly diminished. You can't tell the owner's structural engineer, I'm withholding your payment if you don't drop your model on time. That's not your contract.
So your job shifts.
Your job shifts to coordinating via defined communication protocols and, crucially, managing that coordination through the owner themselves. You become the reporter of non-compliance, not the enforcer.
So you're telling the client, hey, consultant X is late, and this is going to directly impact the permit schedule you asked for.
Exactly. You put the ball in their court to enforce the contract that they hold.
But regardless of those two models, the architect's four consistent duties, what you call the PjM checklist, they remain non-negotiable, right?
Absolutely. Skipping any of these is just inviting failure. Duty number one is to define scope boundaries.
And this is more than just knowing who designs the HVAC system.
So much more. You have to define the interface points, For example, Civil owns the utility connection to the building. MEP owns everything inside. You need to explicitly define who designs the utility main lateral and who designs that connection point stub up.
Because without that clarity,
The work either gets done twice, which is wasteful, or, much more commonly, it falls into a gap that you only discover when you are frantically trying to submit for a permit.
okay, duty number 2, define deliverables. And we need to be really specific here.
Oh, absolutely. It's not just send us your plans, it has to be. We require a model drop in Revit 2023 format, shared coordinates established by the Civil base, including a written narrative outlining the load calculations and all major equipment assumptions by 5:00 p.m. next Tuesday.
That level of specificity is basically a firewall against consultants arguing, well, we delivered something.
It is. If you don't define the format, you might get a hand-drawn PDF that's totally unusable for coordination. If you don't define the underlying assumptions, the narrative, you might only find out at 90% CDs that the MEP consultants sized the HVAC for a non-compliant occupant load.
Wow. Okay, duty 3, define coordination workflows. This is like the project's ritual.
It is the ritual. How often are models dropped? How do we use the project management platform? What is the rule for clash detection? Who is responsible for reviewing and annotating the issue log every week?
So a defined workflow takes coordination out of these chaotic email threads and puts it into a structured system.
Yes. If you leave it undefined, you end up with 300 emails, all titled urgent, that nobody can track, and decisions just get lost. The workflow is the engine that keeps the process moving.
And finally, duty number 4, enforce schedule and QA/QC.
The architect acts as the primary quality gatekeeper for the whole package. This means regular reviews and, crucially, demanding that conflicts are resolved and reconciled before the package is issued.
You cannot rely on the authority having jurisdiction, the AHJ, to be your quality control reviewer.
That is a recipe for disaster. Now, let's talk about that critical legal line. This is where a lot of architects, especially less experienced ones, run into trouble. We call it the liability line. The foundational truth here is that the engineer is legally responsible for the engineering design and for their sealed documents.
Right, that seal is their covenant. It's their professional standard of care on paper.
Precisely. And the architect is responsible for coordinating the total documents and protecting the owner's interests, ensuring fitness for purpose, aesthetics, overall integration. The major danger is directing engineering means or methods.
So you can't tell the structural engineer, hey, I need you to use a moment frame here instead of a shear wall.
You absolutely cannot, because now you are making an engineering decision that is beyond your professional competence.
And if that moment frame fails?
You have fundamentally compromised the structural engineer's standard of care defense because you directed their work. Your role is to identify a conflict, say a shear wall is blocking a desirable window location. You define the architectural requirement, the window, and ask the engineer to provide an engineered solution that meets that requirement.
We identify the problem, they own the solution. That distinction is paramount for risk management.
It is everything.
All right, so to coordinate effectively, we have to enforce this lane discipline. Gaps and overlaps happen when these boundaries get blurry. So let's detail the typical ownership model for the major disciplines.
Let's do it.
Starting with civil. They literally set the tone for how the building meets the earth.
They do. Civil ownership begins with the absolute foundation. Existing conditions, establishing the topographic base, and ensuring coordination with the original survey data. I mean, if the topo base is wrong, every single foundation calculation, floor elevation, and ramp slope will be wrong.
It's the first domino.
It's the first and biggest domino. Their core designs, grading, drainage, and especially stormwater management are essential. Stormwater is a huge permitting risk. If the civil engineer is slow in defining their approach, you risk delays, especially since the requirements are so jurisdiction dependent.
Like in our LA case study later.
Exactly. They also handle utilities up to the building's points of connection. And this is a major interface with MEP. For instance, the civil team designs the fire service main from the street to the building face.
But the MEP team designs the connection and the internal risers.
Right. And if they don't coordinate the thighs, pressure requirements, and precise location of that stub out, you have a physical conflict right at the building envelope before you've even started.
And then the exterior accessibility falls to them, too.
Yes. Paving, curb ramps, fire access routes on the site, that's Civil's domain. But while Civil designs the site EDA routes in the exterior, The architect must still confirm the continuity of that accessible route,
You have to make sure their grades don't create a non-compliant slope right at your accessible entrance.
or that the entrance doors themselves meet the necessary code clearances. It's a critical handoff.
Okay, moving to structural. The skeleton of the building. This is arguably the most fundamental collaboration.
It is. Structural owns the core safety elements: gravity and lateral system design, foundations, and defining special inspections notes, which are required by code. They produce the framing plans, detail schedules, the whole structural design criteria.
But the key coordination point, the one that is guaranteed to cause a fight if it's not managed, is openings.
Absolutely. Structural owns the requirements for structural openings: the location, the size limits, the necessary reinforcement, like headers or trimmers.
But the architect still has to coordinate those openings into the architectural plans and sections where they intersect with our elements, like doors and windows.
And crucially, where MEP systems need to penetrate. If the engineer decides a beam needs to be 30 inches deep, and the architect has designed a 10-foot ceiling with only 12 inches of plenum space,
You have a massive, expensive collision.
a collision that should have been caught much, much earlier.
Okay, now MEP. They're often the most spatially demanding consultants we have.
They are. On the mechanical side, the M, they define the HVAC system, ventilation assumptions, equipment schedules, and load calculations. And that load calculation is vital. It determines the sheer size of ducts, plenums, and air handling units.
And if that calculation is off,
You end up with these massive equipment rooms that just eat into your usable, rentable architectural space.
for electrical, the E, they own the service and distribution lighting controls, but the architect really owns the aesthetic and functional needs.
Exactly. The architect coordinates the reflected ceiling intent, where the lights go, what the required light level is, where we conceal fixtures. The electrical engineer then designs the wiring and circuitry to power that intent.
Which means we have to give them ceiling plans and coordinate clearance heights with structural to make sure all their panels and conduits actually fit.
You do. And for plumbing, the P, they own the systems, the risers, and fixture counts.
And again, that's another classic interface point. The architect determines the required fixture counts based on occupancy load for code compliance.
And the plumbing engineer designs the systems to meet that requirement. And the architect needs to ensure there are properly sized plumbing chases and access panels, especially for future maintenance.
So, if the engineers own their technical lanes, the architect's ultimate role is to be the prime coordinator. What are the architect's specific, non-delegable responsibilities here?
Well, the architect owns the big picture. This means overall drawing set integration, the master sheet list, revision tracking, managing addenda, and ensuring consistent issue dates.
Right. If the structural set is dated October 1st and the architectural set is dated October 15th, you have a coordination failure just waiting to happen.
You do, and you're also setting the digital stage. The architect establishes the backbone, the model, and drawing backgrounds, shared coordinates, level datums, grids. If your consultants are working in different coordinate systems or using different elevation datums, your project is guaranteed to have field conflicts.
Conflicts that cost thousands to fix on site.
Exactly. This setup is the architect's first non-negotiable step in PjM. Then come the true integration items, those collision zones we keep talking about.
Shafts, rated assemblies, penetration strategy, equipment clearances, roof zones.
All of it. These items are inherently three-dimensional and multidisciplinary. The architect draws the fire-rated wall, but the MEP engineer demands a penetration through it, and the structural engineer provides a hold-down bracket that impacts the assembly. The architect has to coordinate the penetration strategy.
How and where those systems pass through, and ensuring the fire rating is maintained.
Yes. And finally, the paper trail. Formal decision capture, meeting minutes, action items, official owner decisions, and formal change documentation. If you hold a meeting and agree on a new location for the air handling unit, and you don't document who is responsible for updating the drawings by when,
That decision will be forgotten.
and you will be blamed for the resulting conflict.
We've established who owns what. Now let's talk about timing. Transitioning from defining scope to defining process timing is where you really move from being a designer to being a project manager.
That's a great way to put it. It's not about the destination DD/CD. It's about the checkpoints you establish along the way. A novice PM only sees the major contractual milestones.
SDDD, 50% CD, permit, bid, CA.
Right. But a seasoned PM understands that the quality of that final submission is entirely determined by the quality of the work you do between those milestones.
Okay, so let's talk about those inner milestone coordination deliverables, the secret sauce, as the source material calls it. What are these essential checks that lock down assumptions early?
First and foremost, design criteria narratives. We need the MEP basis of design, the structural system narrative, and the civil stormwater approach in writing, often by the end of schematic design.
And why so early?
Because it defines the fundamental assumptions, like how much snow load is assumed or what the desired building pressurization is. If the architect reviews the narrative and realizes the engineer assumed a different energy code than the one mandated by the owner, you catch a fundamental error when it costs $500 to fix, not $50,000.
Wow. Okay, and the most practical requirement is model drops on fixed dates. This sounds simple, but it's often resisted.
It is resisted because engineers, like architects, they like to issue a perfect, complete set. But coordination requires models to be shared before they are perfect. A model that is 80% complete but dropped on time is exponentially more useful than a 100% complete model dropped 2 weeks late.
Late information is useless information for coordination.
Precisely. The fixed date mandate forces continuous coordination. And you must pair that model drop with mandatory clash and coordination issue log updates.
Right. The software can flag the clash, but the log is the human interpretation and assignment of responsibility.
And that log must be a living document. Weekly or bi-weekly updates are essential. If you have 50 major clashes, you need to assign 50 owners and 50 due dates. If that log is stagnant, the project is stagnant.
And the ultimate control mechanism here is forcing what you call background sign-off moments, what critical geometry absolutely cannot change after a certain point.
These are formal meetings or checkpoints where we freeze the foundational geometry. This includes grids and levels, the core layout stairs, elevators, the shaft matrix, equipment room sizes, and roof zones for equipment. You get all the consultants in a room, you lock the geometry, and they sign off on the plan.
Which creates a kind of contractual estoppel.
It does. So the practical rule for the PM is this. If it affects another discipline's geometry shafts, duct routes, footprints, slab depressions, structural grids, it must be locked early. If these items are still shifting in design development, you are now paying for your engineer to constantly revise geometry they thought was locked. That's the definition of a fee killer.
So let's formalize this. Successful coordination isn't random, it's a repeatable 6-step workflow.
It has to be. Step 1. The architect issues backgrounds. This has to be the most current, clean version of the architectural plans, levels, and grids, incorporating all prior decisions.
Step 2. Consultants overlay and design. They take your backgrounds and model or draw their systems respecting the locked geometry.
Step 3 is the crucial coordination review. This is where the detective work happens. Clash checks, exchanging annotated PDFs, and logging new conflicts in the issue log.
Step 4. Decision and assignment. A targeted meeting is held using the issue log as the agenda, and the outcome is formalized meeting minutes defining who changes what by when.
And this step is where the architect really utilizes their PM authority to assign the fix, often based on what minimizes the overall project impact.
Okay, step 5. Reconcile and reissue. The updated backgrounds are shared, the consultant models are reissued, confirming the resolution. This is the quality check. Did the fix actually stick?
And finally, step 6, the milestone QC gate. Before you hit send on that DD package, your firm conducts an internal quality check. And this isn't just checking your own sheets. It's confirming consistency of critical items across all discipline sets.
And the true test of a project manager, what the sources call the exam twist, is understanding the architect's required NXE step when the process fails. A consultant is late, they submit non-compliant work, or they just ignore the issue log.
Yes. The correct professional response is never panic. It's immediate, structured documentation and decisive management action based on the contract type you have in place.
Let's dive deeper into that liability boundary. You are the conductor of the orchestra, but you can't play the structural bassoon or the MEP flute. So what happens when your instincts tell you an engineered solution is, well, flawed?
This is high stakes. If you suspect the engineer has made a serious error, say the roof structure seems dramatically undersized for the equipment that has to go on it, and you ignore it, you may be derelict in your duty to the owner, even if you aren't the engineer of record.
But if you try to redesign it yourself, you assume all the liability.
Exactly. So the structure of the correct professional response is vital for preserving your own standard of care while still protecting the owner.
So first, you must flag the issue, and this has to be done formally.
Formally, use an RFI-like internal note or a detailed coordination comment on the model. Your note should point out the observed discrepancy or potential conflict, not the engineering flaw itself.
So you wouldn't say your beam is too small.
Never. You would say something like, the equipment weight noted in the AHU schedule appears to exceed the capacity implied by the shallow beam depth shown on the structural drawing at grid B4. You state facts.
Okay, second, you immediately ask the engineer for clarification or revision in writing.
In writing.
Yeah.
You are putting the issue back in their court, demanding their professional sign-off or their correction. The written record is your defense. You requested clarification, and the engineer either confirmed the approach or they provided a revision.
Third, you coordinate the impacts. So if the engineer has to deepen that beam, you, the architect, have to immediately update your drawings to account for the reduced plenum space or the lower ceiling height.
And you track the schedule delay caused by the redesign and inform the owner of any potential cost implications. You're managing the consequences.
And fourth, you escalate appropriately.
Yes. If the issue remains unresolved, and you genuinely believe the engineer's inaction poses a threat to life, safety, or structural integrity, you escalate. PM goes to the principal, and the principal notifies the owner in writing that there's an unresolved technical issue.
So you have fulfilled your duty to warn the owner.
You have. And the liability trap, what not to do, cannot be overstated. Never redraw their engineering and instruct them to stamp your workaround. We see this with impatient architects redrawing structural sections to fit ductwork.
Or resizing a trench drain themselves.
The moment you impose an engineering solution and demand they adopt it, you blur that line completely. If there's a subsequent failure, the defense counsel for the engineer will argue that you overstepped your bounds and directed their means and methods. Your license doesn't cover engineering.
Focus on defining the problem and facilitating the resolution by the responsible party.
That's the mantra.
Okay, let's apply this whole process to a concrete high-stress situation. We need to visualize the chaos to understand the disciplined response that's required.
Let's do it. Imagine a demanding project. A 4-story mixed-use podium. This is a complex typology retail on the ground floor, parking 45 residential units stacked above.
And we're in Los Angeles, California, which means high seismic design requirements, a typically small, tight urban site, and intense mandatory stormwater regulations that require very early decisions.
The pressure cooker explodes at 60% DD. We're on a tight schedule, and 3 major coordination issues simultaneously hit the log. It's a perfect storm.
Collision 1. Civil is late. They haven't issued the final stormwater strategy, so we don't know the roof drain connection locations or the required piping slopes and sizes.
Which means the roof structure and drainage components are incomplete for a permit submission. It's a showstopper.
Collision 2. Structural ships 2 shear wall lines. Maybe it was for seismic optimization or a clash with foundation elements, who knows. But this shift unintentionally shrinks a crucial code element. A required stair landing clear width is reduced by a critical 2 inches.
A life safety issue. And collision 3. MEP upsizes the main supply duct. The revised load calculation means the main horizontal duct serving the residential corridor is now bigger. It requires a deeper plenum than the structural beam depth allows over a major egress corridor.
It just will not fit.
It physically cannot occupy the same space at the same time.
And the owner's ultimatum. Permit submission in 6 weeks. No schedule slip. How does a competent architect respond?
Okay, step 1. Treat this as a management problem, not a drafting problem. The immediate action is to stop the redlining panic and create structure. We open or update the coordination issue log.
And you make sure that log is granular. Issue ID, the discipline owner responsible for the fixo, structural for the stair, MEP, and structural for the duct.
Right. And the required decision, a firm due date, and the stated impact, immediate permit risk or life safety violation. This log is shared instantly.
Step 2. Run a surgical coordination meeting within 48 hours.
And the agenda for this meeting is only the 3 high-priority collision points. No general status updates. We're chasing decisions, not information.
Okay, step 3. Prioritize life safety and code. That 2-inch reduction in the stair landing is the most urgent issue.
The architect must immediately verify the code violation egress, EDA clearance. If it is non-compliant, the architect must push structural to adjust. You state that the architectural code requirement for egress overrides their structural optimization. Structural has to provide a compliant solution.
Because code compliance is non-negotiable.
It is the one thing that is not up for debate. Step 4. We need breathing room. We impose background freeze boundaries immediately.
Hmm.
We lock the grid, levels, core, shafts, and MEP room footprints for the next 2 weeks.
And you issue a memo stating that any changes to these boundaries require PM approval and a formal schedule impact note.
This prevents a fourth or fifth issue from compounding the chaos you're already trying to manage.
Step 5. Resolve the duct beam conflict.
The architect facilitates the conflict resolution meeting. We present the option set. Option A, MEP redesigns the duct routing to avoid the beam. Option B, structural investigates a beam web opening or switching to a joist system, which might increase cost.
Or option C. The architect accepts a local ceiling bulkhead in the corridor to accommodate the duct, trading some ceiling height for coordination ease.
Right. And once the owner and consultants agree on, say, option C, the architect immediately documents it in the minutes and assigns the revision responsibility. MEP engineer to confirm new duct elevation by Friday, architect to update reflected ceiling plan to show the bulkhead by Monday.
Clear, actionable, and assigned. Okay, step 6. The complex escalation for the late civil work. This is where that contract model becomes crucial.
It's everything. If civil is our subconsultant, the architect issues a formal written notice of noncompliance and demands a detailed recovery plan within 72 hours. We have authority.
But if civil is the owner's consultant, we can't demand performance.
So we notify the owner in writing. A formal letter, not a casual email. We state that the permit set will be incomplete without the stormwater strategy. We detailing define risk permit rejection. And we request the owner, as the client, to enforce the schedule against their own consultant.
We manage the information flow and risk awareness for the owner.
That's our job. And finally, step 7, the QC gate. Before the DD package is issued, we run a final check. We verify cross-discipline integrity, checking the civil roof drainage paths match the structural slopes, confirming structural openings are accounted for in our plans, and that no rated walls have undocumented penetrations.
This complex coordination really demands formal tools. So let's look at the RCI matrix: responsible, accountable, consulted, informed, as a powerful mechanism to prevent finger-pointing during these conflicts.
It's a great tool for clarity.
So let's apply a mini RACI to a specific common shaft conflict. We have a plumbing vent stack and a structural collector or drag strut, both wanting the exact same space within a fire-rated wall chase.
Okay, so first, we confirm the rated wall requirements. The architect is accountable, A, for defining the assembly and ensuring code compliance. The code consultant, or AHJ guidelines, are consulted.
Okay. For the structural element, the structural engineer is responsible for locating and justifying the collector, and the architect is consulted C to understand the impacts on egress or aesthetics.
Right. And for the MEP side, the plumbing engineers, as responsible, are for designing a code-compliant vent stack route. We need them to propose the reroute feasibility, not the architect.
And for the final step, coordinating the final fixed chase size in the architectural plans.
The architect is both accountable A for the drawing and responsible R for ensuring the model reflects the decision. Structural and MEP are just informed of the final accepted geometry.
So RCI ensures that while the engineer provides the technical solution, the architect owns the documentation and the final decision A.
Precisely. Now let's talk dollars. If you are bad at this coordination, it becomes the hidden fee killer. Let's just run some quick PM math.
Okay, so let's say you budgeted 300 hours for coordination meetings across DD and CD. You end up needing 10 high-level coordination meetings with all disciplines. Each meeting is an hour and a half.
And you have 6 attendees? The PM, the project architect, MEP, structural, civil, and the owner rep.
So that's 10 meetings times 1.5 hours times 6 attendees.
Which is 90 labor hours. If your firm's blended rate for that senior team is, say, $140 per hour, that single meeting sequence costs $12,600 just in sitting and talking.
And that's just the meeting time. That doesn't account for the subsequent drafting hours required to resolve the conflicts you identified in the meeting.
That's right. If you didn't budget for that intensity, or if those 90 hours were wasted because of a lack of preparation, you are burning your profit margin directly.
So the interpretation here is critical. The fix isn't to meet less.
No, the fix is to meet smarter. Every meeting has to have a pre-distributed issue log, a tight agenda with decision points, pre-raid markups requested, and enforced decision deadlines. Poorly managed meetings are literal fee leakage.
Okay, let's run through 3 coordination tactics as quick professional practice scenarios. Think of these as critical thinking checks for our listeners.
Good idea. Scenario 1. A consultant submits DD drawings that don't match the current architectural grid and level datum that you officially issued 2 weeks ago. What's the professional next action?
The answer is not to waste your own time correcting their drawings. You must Request the consultant revise to the current backgrounds and document the discrepancy. If you correct it yourself, you waste architectural time and you fail to teach the consultant that using outdated backgrounds creates risk.
They must own the correction. Scenario 2. During CDs, the MEP engineer proposes relocating a main electrical room. This relocation shrinks an adjacent egress corridor width from 44 inches to 40 inches. What is the architect's priority response?
Code and life safety always win. You must reject or redesign to maintain code-compliant egress, then coordinate alternatives. An egress violation is a stop work order waiting to happen. It's an unacceptable risk. You define the requirement 44 inches minimum, and the MEP engineer must redesign their system to respect it.
Final one. Scenario 3. The structural engineer confirms a necessary change, say they have to add a new column right next to the core. This will require significant additional architectural drafting hours to redesign half a dozen adjacent wall layouts and door swings. What's the best project management action?
You immediately document the change, evaluate if it's scope-driven versus coordination, and adjust the work plan accordingly. You have to determine, was this change caused by the owner changing the requirements, or was it an inherent design optimization the engineer needed to make?
And if it's truly unforeseen and owner-driven, you submit an additional services request. But either way, you track the architectural hours needed for the revision, and you incorporate them into your work plan to prevent staff burnout and fee erosion.
We have to end by addressing the ethical red line that often gets tested when schedule pressure is at its absolute peak. This is the moment where professional duty is most tested.
Right, the ethics corner. Let's focus on the pressure to submit incomplete documents. Imagine this scenario. The owner is demanding submission, but your MEP engineer privately admits they are behind and asks you, the architect, to issue for permit with a temporary conceptual diagram set, promising to follow up with the full set later.
What is the non-negotiable standard of care response?
The architect must not submit knowingly incomplete or incorrect permit documents. You cannot compromise the integrity of the process. Submitting a placeholder set compromises public health and safety because the AHJ is relying on your seal to confirm the design meets code.
And it misleads the authority.
It does. The correct professional action is documentation and transparency. You document the risk, you propose a viable recovery plan, maybe engaging a temporary consultant to help the engineer, or proposing a phased permit strategy, and you communicate the real schedule implications to the owner.
Your fundamental duty to public health and safety outranks any short-term schedule pressure.
It has to. So after wading through the contracts, the lanes, the conflicts, what are the 4 essential professional practice takeaways that should govern your management style?
Number 1, the architect equals the prime coordinator, but is explicitly not the engineer of record. Guard that liability boundary fiercely by refusing to design means and methods beyond your competence.
Number 2, process rules. Use issue logs and decision deadlines as your primary management mechanism. They professionalize conflict resolution and keep your consultants aligned and accountable.
Number 3, your management and escalation strategy is entirely defined by who holds the contract. Your approach to your subconsultant is completely different from your approach to the owner's consultant. Know the difference before you write that email.
And number 4, code and life safety wins every single time. It overrides budget concerns, schedule demands, and coordination convenience. If it violates egress, it doesn't happen, period.
At the end of the day, project management and architecture seems to be less about technical expertise and more about proactive process documentation and consistent contract enforcement.
It's about anticipating collisions and having structured mechanisms in place to resolve them formally and quickly.
So to make this knowledge stick, here's your final action item. The power of documentation is your greatest defense in architecture.
It is. Draft a 1-page consultant coordination plan template. This shouldn't be a 50-page specification. It should be a single page outlining the rules of engagement we discussed. Mandatory model drop frequencies, the required columns for the issue log, the meeting cadence, and strict background freeze rules.
And taking that action forces you to think like the prime consultant from day one.
And it sets the professional tone for every single engineer you work with from that point forward.
That proactive template is the essential difference between management success and project chaos. Thank you for joining us for this deep dive into architectural records and professional practices of the services of KING-KAMBUF Architecture Design Studios issue, project management, PjM, coordinating with consultants. We'll see you next time on Beyond the Comfort Zone.